Chemistry videos, how to solve a basic stoichiometry problem. Now this is one of the simpler problems that would be found on the mandatory pass exam. If you have watched the doing unit conversion video right before this, you will follow the same format that you learned there, and now we're going to apply the basics of a mole ratio within it. So the basic steps to solving a stoichiometry problem is first is to read the reaction statement and write down the reactants and any products you are given. If you are not given any products, then determine what type of chemical equation it is and then predict the products, be it single replacement, be it double replacement, be it a combustion, and you should be able to determine the products. Once you're done with writing the equation, then balance the equation and then write down the amounts that you have been given so we can use dimensional analysis to actually solve this. Now here's a sample problem. How many grams of ammonia can be produced if 100 grams of hydrogen gas is reacted with an excess amount of nitrogen gas? So right off the bat, I know that my reactants are hydrogen gas and nitrogen gas, and my product is ammonia, and the symbol for ammonia is NH3. Okay, so my chemical equation is going to be hydrogen gas plus nitrogen gas will create ammonia. Now I have written down my reactants, I have predicted my product, and if I wanted to, I would write down that I have 100 grams of my hydrogen gas, and sometimes I'll write a question mark over here to let me know which one am I predicting and also what is the unit they are looking for. So here I'll write down grams. Now we need to balance this equation. So once again, we had hydrogen gas plus nitrogen gas created ammonia. Now, as always, first thing we would want to do is do any metals, and as we can see in this equation, there are no metals. Remember, metals are the ones that are on the left-hand side of the stair steps that are on the periodic table. So next we go to the non-metals. Once we're done with the non-metals, then we would work with the hydrogens, and last we work with the oxygens. So the first nonmetal I have that's a non-hydrogen or oxygen is nitrogen. And here I have two of them. So I need to come over here and put a 2 over here to have 2 nitrogens here. Now my nitrogens are balanced. Okay, so I'll put a check there. I have those balanced. Now I go to my hydrogens. Now here I have 2 hydrogens, but over here I have 2 times 3 is 6 hydrogens. So to get this balanced, I need to put a big 3 over here. Now my hydrogens are balanced, and all of this is balanced. So I now have a perfect balanced equation. And what this tells me is that 3 moles of hydrogen gas plus 1 mole of nitrogen gas will create 2 moles of ammonia gas. Okay, now determine the number of moles, grams to moles, okay? So we could do this either on one long equation, which I'll show you on the next sheet, but right now we were given 100 grams of hydrogen gas. So if I was to take my 100 grams, remember, draw your fence line, put your first fence post in, write down the unit and the number of what you was given. Immediately put the unit in the second box at the bottom, okay, because I need to get rid of this. Next I put where I want to go. I need to go to moles, so I put it on the top box up here at number 2. Now I need to figure out, okay, I have 100 grams of hydrogen gas, okay, and I need to turn that into moles of hydrogen. So I know that 1 mole of hydrogen gas would be whatever the weight is according to the periodic table of 2 hydrogens. Each hydrogen weighs 1 gram per mole, so this would be 2 grams. So now I can see that grams of hydrogen cancel here, grams of hydrogen cancel here. That leaves me moles of hydrogen here, and 100 times 1 is 100, divided by 2 is 50. So I would have 50 moles of hydrogen gas. set this up and do the dimensional analysis and do it the way that you should, we take and we're going to write, first of all, I'll rewrite our balanced chemical equation up here. So we have 3 hydrogen gas, moles of hydrogen gas, plus 1 mole of nitrogen gas will create 2 moles of ammonia. Now we're going to do the dimensional analysis. So first of all, I draw my fence line, put in my first post. Okay, remember we had 100 grams of hydrogen gas. So even though I showed you how to take it and put it into moles the other way, you know, by just one at a time, I'm going to lay it all out right now and show you how you should do it so you can get it done really quick. So the first thing I'm going to do is I'm going to write down the unit, grams of hydrogen gas, and then the number that I have. So I have 100 grams of hydrogen gas. I immediately want to take the unit and write it down in the bottom second box. So I'll put my other fence post in here. So now I got to figure out, which we already have, I need to go to moles, because we go to grams to moles, moles to moles, moles to grams. So remember that. We go grams, I have to go to moles. Using my balanced chemical equation, I have to go moles to moles, and then on my product side, I go moles to grams. This is on the product side. This is the reactant side. So then, we already figured out that 1 mole of hydrogen gas weighs 2 grams. So then, I have now went from grams, which was given to me, I'm now at moles on my reactant side. Now I'm going to jump across from reactant to product, okay? And I have to use what they asked me for. And they wanted to know how much ammonia here was we were going to make. And they wanted to know in grams, okay? So now I'm going to go moles to moles, as it shows me down here. And it tells me, I put where I want to go on top. So that would be ammonia. And I immediately take, like we talked about, what we have over at the top here goes down at the bottom over here. Okay, put my other fence post in here. Now I need to look and see what my balanced chemical ratio is. And this tells me that there's 2 moles of ammonia for every 3 moles of hydrogen gas. So now I'm at moles over here because these are all in moles. I just jumped from this area here all the way over to here. Now I got to go to grams. So I want to put grams at top, grams of ammonia. And I'm going to take what I have over here, moles of ammonia, down here at the bottom. And I need to figure out, okay, well, how many grams are in 1 mole of ammonia? And if I add up right here that this weighs 14 and this weighs 1, but I got 3 of them, that equals 17 grams. So I know that there's 17 grams of ammonia in 1 mole of ammonia. Now I have my problem all laid out. I am at grams of ammonia right here, which is what they asked me to get to. So once I see that I am here, I know I'm done. I don't have to lay any more out. So now I do the math. The first thing I do is cross-cancel all like units. Anything that's above the number line and below the number line, I can get rid of. So here I have a grams of hydrogen. There's a grams of hydrogen. I don't have any more grams of hydrogen anywhere around. Here I have a mole of hydrogen. Here's a mole of hydrogen, okay? Here I have a mole of ammonia. Here's moles of ammonia. So as you can see, all of my units now cancel out, and the only unit that I have left is this one right here, which is the one that they asked me for. How many grams of ammonia can we make? So now I do the math. I'm going to multiply everything that's up above the line. So that would be 100 times 1 is going to be 100, times 2 is going to be 200, times 17 is going to be 3,400, right? I believe that math in my head is correct there. And then I take down here and I multiply these. 2 times 3 times 1 is going to be 6. And then I would end up then I would end up and do my math over here on this side. So 100 times 2 is 200, just so you can follow along here. 200 times 17, if we take 17 and you do that in your math, okay, that's 3,400. Okay, we take 3,400 grams is what we end up with here. Now I have to divide that by 6. So if I take 34, divide that by 6, I'm going to end up with somewhere around 566.1 grams of ammonia is what I can make from 100 grams of hydrogen gas. Now what you need to do as many times as you possibly can, okay? Go back and forth over it. And if you have other questions, jump back into the video that talks about unit conversion problems, okay? Use these two together. Then write down any questions you have and bring in any practice problems you have into class, and we'll go ahead and get them answered there, because this is the basic stuff you need to be able to do to pass the mandatory pass exam. Okay, remember, chem is try, and never, never, never give up. Keep trying out there. Stay gritty.